Alright, today we are ready to talk about section 10.4. Now in this section we are going to talk about how to add and subtract radical expressions. Now what exactly is a radical expression? You can talk about radical expression being an algebraic expression that will contain radicals. So if you have something like 4 square root of 2 plus 4th root of 3, you can take that to be a radical expression, or something that has variables in it. Square root of 2x minus y plus 3 will again be a radical expression. Alright, and then let's see how we can simplify radical expressions involving addition and subtraction. Now, radical expressions that have the same index and the same radicand, only those can be combined. So you cannot have a radical expression, that has a different index or maybe even a different radicand and try to combine those together. So this is very important that you realize it should have the same index and the same radicand when you're trying to combine with addition or subtraction. So let's go ahead and look at an example here. Now let's say we are talking about this example, 2 square root of 5 plus 3 square root of 20 plus 4 square root of 45. Now you will see that I have already started simplifying this. You have 2 square root of 5. Now 5, you cannot break it down any further, so we leave it as it is. But look at 20 here. 20, we can write it as 4 times 5. Break it down a little bit further. And again, the reason why I'm using 4 times 5 is because 4 is a perfect square, and I can take square root of 4 and bring it outside. Same thing here with 45. I can go ahead and write it as 9 times 5. And again, in that situation, I can take the 9 outside of the square root and I can simplify it further. So I want to try and break these numbers down as far as I can. Now let's see what we can do next. You have 2 square root of 5 that stays the same. Okay. Now square root of 4 will come outside. You have 3, or basically square root of 4 will become 2. Okay. And since 5 cannot be simplified any further, that will continue. 4 coming outside as 2, and square root of 5 still stays under the radical sign. On the last term, again, you have 4 on the outside. Square root of 9 is 3. So you bring the 3 on the outside. And again, 5 cannot be simplified. So we go ahead and leave it the same. Leave it under the radical sign. All right, let's see what happens next. 2 square root of 5. Now we can go ahead and multiply 3 and 2, which will give us 6 square root of 5. Plus 4 3s are 12. And that will give you 12 square root of 5. Now this is what we were talking about. Once we get down to this stage, we said that only radical expressions with the same index and the same radicand may be combined, right? So here, your radical is the exact same thing. You have square root of 5, square root of 5, and square root of 5. Basically, the idea is you can see you have the same index, which is square root, and the radicand, which is 5, is also the same. When you're working with adding and subtracting radical expressions, you treat your radicals like they were x's. What if you had, 2x plus 6x plus 12x? How would you go ahead and combine them together? You would just add the coefficient terms, right? So that's the same thing we do here. You have 2 square root of 5, 6 square root of 5, and 12 square root of 5. Think of square root of 5 as being a variable, something like an x or something. And in this case, you go ahead and add all the coefficients. So you have 2 plus 6 plus 12. Go ahead and add all of them. And then you have your square root of 5 on it, which will of course give you 12 plus 6 is 18, 18 plus 2 is 20. And your sum is going to be 20 square root of 5. So it's the same thing as I was telling you. 2x plus 6x would give you 8x. 8x plus 12x would give you 20x. But instead of x, this time you have a radical expression. Okay, let's go ahead and look at another example here. In this example, we're doing both addition and subtraction. So let's see what we end up with. Again, try and simplify everything that you have inside the radical sign and see if you can, put it in more smaller terms. So 18, we can go ahead and write that down as 9 times 2. And don't forget the k. Again, 9 times 2 because 9 is a perfect square. With 72, there's many different ways you can do this, but 72 is 36 times 2. Okay. And you can go ahead and break it down because 36 is again a perfect square, so that will come outside as 6. Now you know 72 is 8 times 9. 9 being a perfect square, you can go ahead and do it that way also, but then you would have to simplify the 8 further. So 36 times 2 is the more easier approach to go with. So 36 times 2 and then your k. And then your last term is 50k, which you can of course write it as 25 times 2. 25 being your perfect square again. So once you go ahead and break down your radicals, now let's go ahead and bring them outside the square root sign. So 4 in the front. Square root of 9 is 3. And then 2 and k will not be simplified, so you go ahead and leave both of them inside the radical sign. Then you have minus, and then let's see, 36. Square root of 36 is 6. And again, you will be left with 2k inside the radical sign. Same thing on the last one. 25 will come outside of the square root as 5. And square root of 2k is what's left. Now again, just like we saw in the earlier example, you can see a similar pattern here. You have square roots on all your radicals, and then your radicand is 2k, 2k, 2k. So again, same index, same radical, we can go ahead and combine our coefficients. So 4 times 3 will give us 12, square root of 2k, minus 6, square root of 2k, plus 5, square root of 2k. So just like we did earlier, combine all your coefficients. And then you have square root of 2k. 12 minus 6 is 6. 6 plus 5 is 11. And 11 square root of 2k will be your answer here. Okay? Now these two problems that we saw were dealing with square roots. Let's go ahead and take a look at an example with a cube root. In this one, you have 3 cube root of x squared y squared minus 2 cube root of 64 x squared y squared. Again, you want to try and do the same thing that we did with the square roots. Go ahead and simplify your radical if you can. Now in the first one, you have x squared y squared. You can see that both these exponents are less than 3. So that tells you you cannot simplify this any further. So this stays the same. Okay. On the other side, you have 64 x squared y squared. Now go ahead and see if you can write 64 as the cube of something. And you will notice that 64 is the cube of 4. 4 to the third power will give you 64. So if I go ahead and simplify this, my first term stays the same. I have 2 on the outside. Now cube root, we're not talking square roots here, people. We're talking cube root. So cube root of 64 is 4. And then you're left with the x squared y squared inside your radical sign. Okay, go ahead and multiply your 2 and 4. So your first term stays the same. Your second term will be 8 cube root of x squared y squared. Now again, before you combine the terms, make sure that your radical has the same index and the same radicand. So your index is the cube, the 3, and your radicand is x squared y squared. So they're the same. You can go ahead and combine your coefficients. And you will end up with -5 cube root of x squared y squared as your answer. So same logic applies. Doesn't matter if you're talking in terms of square roots or cube roots or any of the other higher power roots. Now I want to look at a different type of example here. This one has fractions in it as your radicands. So you will of course apply your quotient rule and stuff that we learned last time in last section to help you out with this one. So we'll go ahead and apply our quotient rule first, where we go ahead and break down our numerator and denominator into separate radicals. Okay, so you end up with square root of 100 over square root of y to the 4th, and for the other one you end up with square root of 81 over square root of y to the 10th. Now square root of 100 we know is 10. For the denominator, go ahead and rewrite it in the rational exponent form, so you'll end up with 4 over 2. Okay, again remember square roots, when you write them as rational exponents, have a denominator of 2. On the other side, square root of 81 is 9, and you will end up with y 10 over 2 for your rational exponent. Now you can see once we write these as rational exponents, it's much easier to go ahead and reduce those numbers down. So we end up with 10 over y to the 2nd. Okay, 4 divided by 2 will give you 2. For the other one, you have 9 over y to the 5th. 10 divided by 2 gives us 5. Now, just like we do with any fractions, any rational numbers, you try and add the two rational expressions together. Now you can see your first denominator is y to the 2nd, your second denominator is y to the 5th, so your least common denominator is going to be the higher power. So y to the 5th is your denominator, which tells us we need to multiply our first expression by y to the 3rd, because again remember 3 plus 2 will give us 5, so you end up with 10 y to the 3rd over y to the 5th plus 9 over y to the 5th. And when you add these two together, 10 y to the 3rd plus 9 and the whole thing over y to the 5th. Okay, and this is what we basically did in chapter 6. So we're just basically following that same idea here. And this will be your final answer. So you started out with a radical, but you ended up with more like a rational expression. Alrighty.